Right, so the next section of your workbook starts off with a quick review of powers and exponents. So I thought I'd give you a quick rundown just because I know this is something we haven't looked at since September. So you probably need a brief rundown on how it works again. So we are working with powers. Okay, so remember, if I have something like a with an exponent of n, so we're talking about n as the exponent, and a we refer to as our base, and the whole thing together makes a power. Okay, so the power is made up of the base and the exponent. Okay, as a reminder, so when we are looking at our base, okay, our base can be it can be a negative, it can be a fraction, it can be a positive number. So we have to be very careful with our base. Okay, so the base is always in a set of brackets, and if it's not in a set of brackets, it is the number that the exponent touches directly. Okay, so we need to be very careful with our base. Remember that the exponent touches directly. Okay, so when we're looking at questions involving powers and exponents, we have to be very certain of what our base is. Whether or not we need to include a negative or whether it's part of what we would call the coefficient. Okay, so we might have something that looks like this. So we could have 7x squared. In this case, because the 2, which is our exponent, is directly touching the x, that means we would refer to the 7 as a coefficient. It is not part of the base. Okay, now this would be different if I was to write 7x in brackets and then square it. Okay, in this case, because the exponent is touching the brackets, everything inside the brackets would be included as part of the base. Okay, so we have to watch out for our bases and whether or not they are part, or whether or not the exponent is acting upon them. Okay, so remember, an exponent really means whatever the exponent is touching is repeated that many times. Okay, so the exponent tells you how many times the base is multiplying by itself. So 10 exponent 4 would be the same thing as 10 times 10 times 10 times 10, where there's 4 10s all multiplying together. Right? If we had something like 3 exponent 5, that would give us 3 times 3 times 3 times 3 times 3, and that would be 243, right? So that means that the base multiplied by itself 5 times. Now, here's, if I had negative 6 with an exponent of 2, okay, again, this 2 is directly touching, the exponent of 2 directly touches the 6, which means that the negative that is sitting in front is a coefficient. So that negative is going to stay in the front while the 6 multiplies by itself, okay, because the exponent touches that 6 directly. So this is going to give me a value of negative 36. This is different from having negative 6 squared, where the negative 6 is in brackets, because this tells me everything in the brackets is repeated as part of the base. Okay, so one gives me positive 36 and the other gives me negative 36. So where your negative is completely changes the context of your question. So make sure you're identifying what is and is not part of your base. Okay. The other thing that we worked with in powers was our exponent laws. Okay, so remember, we've got first off our product law. And the product law simply states that if we have two things with the same base, we can write it out. So if I had 2 cubed times 2 exponent 4, 2 cubed would be 2 times 2 times 2, and then 2 exponent 4 would be 2 times 2 times 2 times 2. Okay, and because in between those brackets we're still just multiplying, this really becomes a long string of 2's all multiplying together. So this really becomes like having 7 2's. And so what happened was we basically added our exponents together. Okay, so we are allowed to add our exponents together if we are multiplying and the base is the same. So that's our first exponent law, is the product law, and it's a exponent m times a exponent n would be equal to a with an exponent of m plus n. Okay, so that would be the product law. Next one we have is called the quotient law, and the quotient law is similar. And we'll do an example. So if I had something like 3 with an exponent of 6 divided by 3 squared. So again, that's the same thing as 3 exponent 6 divided by 3 squared. Well, if I was to write that out and expand it, that would be having 3 times 3 times 3 times 3 times 3. I can't remember how many I've said now. Anyway, there's 6 on the board. And then in the bottom there's 3 times 3. Okay, well, I'm going to put this into lowest terms, and I'm going to put it into lowest terms by removing a common factor from numerator and denominator. So they both have a common factor of 3. So I'm going to cancel out that factor of 3, and they become 1s. And then I can do it again. I still have another common factor of 3 between numerator and denominator. Now denominator is only 1s, so I'm left with 3 times 3 times 3, which is 3 with an exponent of 4. Okay, and so what I did here was we took 3 exponent 6 divided by 3 exponent 2. Now I had it written as a fraction, so it can also be written as a division with the division sign. But really what we ended up doing was subtracting our exponents, and that gave us 3 exponent 4. Okay, so this would give us our second exponent law, the quotient law, and it's a exponent m over a exponent n is equal to a with an exponent of m minus n. Now again, we could also have that written instead of as a fraction, as a division statement. Now we do have the important caveat here where we say that a can't be 0. I'm not allowed to do this with a base of 0, because if I am, I'm dividing by 0, and as you might recall, that could start a calculator fire. So we don't want any calculator fires while you're sitting at home in quarantine. Okay, the next law that we have is called the power of a product, and you're going to start using that one a lot more now that we're bringing in more variables into our exponents. Okay, so a power of a product would be something like I've got 3 times 7, and then I'm going to cube that. Okay, so because that exponent of 3 is directly touching the brackets, it means that everything inside the brackets is going to be multiplied by itself 3 times, right? So I have 3 sets of those brackets multiplying each other. Now, because all I'm doing is multiplying, I'm allowed to drop those brackets because I can multiply in whatever order I like. And because I can multiply in whatever order I like, which means multiplication is called commutative, things can travel, okay, I'm allowed to move all my factors around. So I can gather all the 3's together, and then I can gather all the 7's together, and it just so happens that there are 3 3's and 3 7's. Okay, so the power of a product is basically telling us that the exponent goes on to both things in our product. Okay, now that one's going to come in handy as we start looking at powers and we've got a coefficient as well as a variable. Okay, but remember when we did this earlier in the year, it was also beneficial for us to have something like that, because if we had something like 5 with an exponent of 4 times 6 with an exponent of 4, we always think of this law as going one way, and that's kind of a mistake. I want you guys to be able to realize that you can go backwards with it too. So because they both have the same exponent of 4, I can put them back inside the brackets, and I could write it as 30 with an exponent of 4. So it's a way of splitting powers apart. Okay, so the way we write this one out is we would have a times b to an exponent of m, and we would then get a with an exponent of m and b with an exponent of m. Often what you guys do is you remember this law and you think, oh, I always have to go this way. I'm only allowed to go from the one on the left to the one on the right. But an equal sign means I can go back and forth both ways because they are equal. Okay, so that's power of a product. The next one is power of a quotient. Okay. All right, so power of a quotient is very similar. This one basically allows us to deal with our fractions. So let's say I had something like 2 over 3, 2/3, and I'm going to put that to an exponent of 4. Well, I'm going to then take everything in the brackets, and I need to have it 4 times. Okay, and since all I'm doing is multiplying, I can drop the brackets. And since all we do when we multiply fractions, generally we look for any cross-reducing, but there is none here, so it would be all the numerators multiplying together, and then it would be all the denominators multiplying together. And now I can write that numerator as 2 exponent 4, and the denominator is 3 exponent 4, because there are 4 in both numerator and denominator. Okay, so what happens here is the exponent really just goes onto both things in my fraction. It goes onto the numerator and the denominator. Okay, oops, not a, it's a 3. Okay, so this law, as we write it out, we would have it as a over b to an exponent of m is equal to a with an exponent of m divided by b with an exponent of m. Now this is also true if we have it written as a division instead of a fraction. Okay, now again we have the important caveat where b cannot be 0. Okay, we are not allowed to have that 0 as our base for the denominator because we are not allowed to divide by 0. Okay, we got 2 more, so really quickly we've got power of a power. Okay, now this is where we've already got a power inside a set of brackets and we are raising it to a further exponent. So for example, let's say I had 3 squared and then I am going to raise that to an exponent of 3 again. Okay, so the first thing that happens here is inside the brackets that exponent of 2 is directly touching the 3. So what I would get is I would start off and I'd have 3 times 3 inside the brackets, and now I got another exponent of 3 outside. And that exponent of 3 is touching everything, or is touching the brackets, so that means everything in the brackets is repeated. Okay, now we also saw from our power of a product rule that that exponent of 3 needs to go onto both things in our product. And then our very first rule that we learned, the product law, says that since these bases are the same, I can add those 2 exponents together, giving me 3 with an exponent of 6. Well, 3 with an exponent of 6, if you look, here's what we had. We had 2 as our first exponent, and 3 is the second one. It's really like multiplying the 2 and the 3 together. Okay, so that is our power of a power law. So if I have something with a base of a and an exponent of m, if we further raise that to another exponent n outside the brackets, it becomes a with an exponent of m times n. Okay? Alright, the last one that we have is our power, or we have the 0 exponent. Okay, now there's a couple of different ways that we could work with this one. Okay, so the 0 exponent, for purposes of you guys probably are done watching, anything with an exponent of 0 is 1. Okay, now the one thing that we have to say there is that a can't be 0. We can't have 0 to an exponent of 0. You can use the same kind of chart to argue why that can't happen that I'm going to show you here. So let's say I had something like 2 squared. 2 squared would be 4. And then 2 with an exponent of 1 would be 2. Okay? And if I wanted to go 2 with an exponent of 3, that would be 8. Right? And so as I go up, as I increase the exponent by 1, I multiply by 2. As I increase the exponent by 1, I multiply by 2. But if I was to go down this list instead of up it, so if I decrease my exponent by 1, I divide by 2. And if I decrease my exponent by 1, I divide by 2. So when we decrease our exponent by 1 again, and we get 2 exponent 0, I have to divide again by 2. I keep the same pattern. And 2 divided by 2 is 1. Now this is going to work for any number you can think of, so if you want to pick a different one, go ahead. We also have our other exponent laws can help us argue this one too. So let's say I had something like 3 exponent 3 divided by 3 exponent 3. Well, that would mean I've got 3 times 3 times 3 divided by 3 times 3 times 3. It's the same thing, right? I'm going to get 27 over 27, and that's just 1. Well, another way of writing 3 exponent 3 divided by 3 exponent 3 is using that using that quotient law. And the quotient law says since the bases are the same, we subtract the exponents. And 3 minus 3 gives me 3 with an exponent of 0. And that is also equal to 1. It's two ways of writing the same thing. Okay, so it doesn't matter what base you choose, whether it's negative, whether it's a fraction, decimal. If it has an exponent of 0, then the answer is going to be 1. Okay, provided that your base was not already 0 to start with. All right, so that's a really brief rundown of everything we did with powers, as well as the 6 different exponent laws that you should be well aware of by now. All right, bye.